All right, well, good morning, everyone. Welcome back to another exciting day of mathematics. Whoop, whoop. Make sure you go to Canvas and click on the Zoom link so you can check into the class. Warm up number 13 should be your screen. The first two is to simplify, and then number 3 is to solve. I'll give you guys some time for that. That shouldn't take you more than about 5 minutes. Copy and go. And for today, just giving you a heads up. Today's going to be a little bit challenging towards the end, so I need you to stay focused. Okay. All right. Let's continue. Go. All right. Let's see. Number 1. What'd you get for number 1? Joel, go. Standard form, please. Okay, I heard 2x. What else? Minus 4x squared. Minus 4. Okay. All right, close. You got it? Okay, go. What is it? It's still close. Okay, I'll write it out. Negative 4x squared. What is it? Minus 2x. Minus 4. And you got that? All right. So let me find out what happened here. So the first thing that you should have done is to show this negative. Yes. So that leaves us with 5x squared minus 6 minus 5x. Okay. Next, combine. What is 9x squared and 5x squared? That is 14x squared. What is negative 2x and negative 5x? That's negative 7x. And last but not least, negative 10 and negative 6. That's negative 16. Hands if you got that one. Okay, not bad. Don't forget to distribute those negatives, please. Let's go to number 2. Pass someone, Joel. Diego, Rosas, what'd you get? Standard form, please. Y to the second. Minus 15, 18. Close. So you remember what he forgot to do for the first term. What is negative times a negative? Positive, yes. Negative times a negative is a positive 3. So this should be a positive 9. Yes, because this is 6 and 3 that we distribute over here. That's 9. And the rest is correct. Say it again. Yeah. Yeah. Number 3, I need the solution set. Tell your neighbor what you got for your solution set before I call on someone. All right, pass someone, Diego. Fredo, what'd you get? You didn't finish it? Okay, help him out. Pass someone else. Okay, go. Jose. Jaden, go. Oh, wow. Thank you, sir. Oh, keep it. Yeah, thank you. All right, let's see from that table over there. How about Juan? What'd you get? Restroom, okay. Help him out. Alyssa, what'd you get? Why such that? From the corner, Alyssa, let's go. That is correct. All right, copy the agenda for today, please. Here we go. We got warm-up number 13, product of polynomials. We're moving on. And tonight's home play is pages 290 and 291. I only want you to do numbers 1 through 7. Only 1 through 7. Thank you, Mr. Q. You're welcome. Yes. Now, I've gotten a couple of emails yesterday in regards to home play. Some students were like, Mr. Q, I can't find the home play. Well, let me show you. So let me bring Canvas over here. Your Canvas should look like this. Look up to your screen. There it is. There am I. And on the top left, we have the buttons Home, Modules, Grades, and Nearpod. For home play from this point forward, most of the time, I'm going to ask you to go to Modules. You click on Modules. And you should have 3 folders. One for week 1, close that one, or collapse it. Week 2, we're done with week 2, collapse that. And now we are in what module? Polynomials. In there, you're going to find all that we've been doing so far. The ones that have a paper clip are attachments, which is the play sheets that I give you. And the ones below that are the assignments. So today's assignment that you need to turn in at this moment, go to Canvas, turn it in, add and subtract polynomials, turn that in right there. And tonight's home play is right below it. Okay? This is going to be recorded and uploaded on YouTube. So if you forget how to get to the home play, go watch the video. Please. All right. I'll give you guys some time for that and get a Cornell note ready, please. And we'll move on. Oh, you didn't finish copying the agenda? Okay, sorry. There's the agenda. Okay. All right. Thank you. Jose. All right. So turn in your home play and once again, get a Cornell note ready. There's the objective, write that down. All right, here we go. Our objective for today, I can multiply polynomials. I can multiply polynomials. Tell your neighbor what concept we're so on, please. Yeah, polynomials. So that's why for your Freyer model, we don't need one, right? We already know what the definition is without looking at your notes. So do me a favor, don't copy it. Just turn to your neighbor, let them know the definition for polynomials. Definition for polynomials. All right, so hopefully they said something like this. There's the definition. They said monomials and add and subtract monomials, something like that. Yes. All right. And then yesterday and the day before, we covered some terms that we've been talking about, which is terms, like terms, coefficients and such. Yes. All right. And just to remind everyone, look up to the screen. From this point forward, very important, very important. Anytime you see a variable without an exponent, I want you to write the exponent of what? 1. Do that, please, because if not, you're going to start missing steps. Okay? Everybody with me? Yes? All right. So here we go. Y'all ready? Okay, we're going to jump right straight in there. I'm going to start slow. You know, kind of like if you're at the beach in the beach cruiser eating your burrito. Slow. Copy this one, example 1A and B, and it reads multiply the polynomials. Part A reads 6y cubed, close parentheses, open parentheses, 3y to the 5th. Part B reads parentheses 3mn squared, close parentheses, open parentheses, times 9m squared n, close parentheses. All right. So here we go. I'm going to go slow on this one just to make sure we get all the misconceptions out of your noodle and get it straight, because it's going to start accelerating pretty quick. Here we go. First things first. There's going to be times that they give you some expressions like this that don't say what to do. So the first thing I want you to check is to see if there's addition or subtraction in between the parentheses. Is there addition or subtraction? No. So automatically we assume now that we are in multiplication mode. Ready? All right. So I'm going to take blue. I want you to circle the first expression, this one. It's a monomial. And we're going to multiply that times the second one. And we're going to multiply numbers times numbers, variables times variables. Ready? Here we go. What is 6 times 3? 18. Y to the third times y to the fifth is y to the eighth. Now that we are multiplying, tell your neighbor what to do with the exponents, please. What do we do to the exponents, everyone? Add. So if we have the same variable, we add the exponent. Let's do the second one. Here we go. Circle the first one, and we're going to multiply that times the second monomial. Once again, numbers times numbers, variables times variables. What is 3 times 9? 27. What is, check this out. M, what is the exponent on M? So put a 1, don't forget that. So M times M to the second becomes M to the third. Then we got N to the second times N, put an exponent on that one. So that is N to the third. All right, from 1 to 5, how comfortable are you with these? 5 fours, 5 fours, okay. So now that I showed you how to do these, I'm going to give you 2 more for you to do by yourself. Copy these, please. Example 1C, 1D and E. We got parentheses 3x cubed times 6x squared and parentheses 2r squared t times 5t cubed. Copy that, finish those by yourself, and go. D and E. All right, good conversations. What you get for our product for E? I'm sorry, for D. D. Let's start with D. Zoe, what'd you get? You got 18 what? X to the what? 5th power. Hands if you got that. That is correct. How about E for this one? E. How about Juan, what'd you get for part E? 10 R to the 2nd power. T to the what? 4th power. Yes, because this is a 1 right there. Hands if you got that. All right. From 1 to 5, how comfortable are you with monomials times binomials? Yes, 5, 5, 5. Okay. All right. Shall we crank it up a little bit? Yes, Mr. Q. All right. Let's move on. Example 2. Copy that. We got 6pq times 2p minus q, close parentheses. And once again, stay focused. Please put away those cell phones. Thank you. Once again, 6pq times 2p minus q. All right. Now, before you start doing all your multiplication, doing all that, we're going to do using a different method. Okay. This is what I want you to do. I want you to draw over here to the right a rectangle. It's a little bit longer than the width. There it is. And I want you to write on this side, we're going to write our monomial, which is 6pq. Above, we're going to write the binomial given, but I'm going to start with the first term. What's the first term? 2p. As soon as you write it, you're going to draw a line down to split the area. And the second part is minus q. And this strategy is called the area model. Okay, here we go. So I'm going to use blue to get this first area. Focus, please. Numbers times numbers, variables times variables. Here we go. What is 6 times 2? 12, okay. P times P. Let me put the exponents of 1 and 1. So that's P to the second, okay. Q to the first, and is there a Q here on the first part? No, so I just write the Q right there. All right, now we're gonna fill in the second part, but we're gonna use the same one right here times this part. So here we go. What is the coefficient here, guys? A 1. What is the exponent of Q? 1. All right, so here we go. What is 6 times negative 1? Negative 6. What is P to the first times nothing here? We write P to the first. And what is Q to the first times Q to the first? Q to the second power. Now, some of us like this one because it keeps us organized. Some of us love distributed property. So let's do this one now over here in distributed property. I'm going to circle the monomial in blue, and I'm going to multiply times the first term here. 6 times 2 is 12. P times P, or P to the first times P to the first, is P to the second. And then bring down the Q because there's no Q right here, okay? Next, the same monomial now times the second term, this one. Put a 1 there and a 1 there. So what is 6 times negative 1? Negative 6. P to the first times nothing there. There's P to the first. Q to the first times Q to the first is Q to the second. Did we get the same answer as over here? Yes. Those are the two methods that we know so far. All right. So I'm going to give you another one. You use whichever, actually, no, use the area model for this next one. Example 2, super cube, omega cube. Write that down, 5r squared s squared times r minus 3s. Using the area model. Help me set it up, please. Dylan, what do I write here? Thank you. And up here, Fabian, help me. What goes here? R, line down, and then? Yes. All right, I'll give you some time and go. All right, help me out, please. Jessica, what goes right here? Five r cubed s squared, hands if you got that. That is correct. All right, so now we go to the second term. What goes here, Fredo? All right, help him out, Jaden. Negative 15r to the second power. S to the third power. Hands if you got that. Okay. So from 1 to 5, how comfortable are you with area model? Yes. 5, 5, 5s. Okay, we'll get there. All right. I'm going to give you another one, and for you to do this one using any method, either distributed property or area model. Yes. Yeah, let me give you another one. Here we go. Let's do 4a squared b times 2a minus 5ab. You can use distributed property or area model. It's up to you. We'll call this one example 2 Shazam Q. All right, let's see what we got. What you get for our product on this one. Let me scroll down. All right, product, what'd you get? Ivan, go. That's why you have you guys talk to your neighbors. Jalen, what'd you get? Yes, please. B to the what? Hands if you got that. Let's go, Jalen from the corner. And she got packed. All right. All right, so I think we got this, yes? All right, so shall we crank it up a little bit? Yeah, let's do this. Example 3, copy this. A plus 4 times A minus 2. Just copy it because we're gonna do this using the area model. Yes, let's do this. I want you to draw a rectangle on the side. Here we go. Over here. Nice. Here we go. All right. So we started with monomial times monomial. We moved on to monomial times binomial. Now we have a binomial times a binomial. Okay. So here we go. Look up to your screen. I'm going to write the first binomial here straight top to bottom. I'm going to start with the first term. What's my first term? A, so I write it right there, and I draw a line across. The second term is what? Positive 4, so I'm going to write positive 4 right there. Now I go to the second binomial, and that one goes on top. What's my first term? A, draw a line down. And the last term of that second binomial is negative 2. So I'm going to use 2 colors, blue and red. Here we go. I'm going to start with blue. Underline A, and we're going to fill in these top 2 boxes here by multiplication. So that times that times that. Here we go. What is A times A? A to the second power. What is A times negative 2? Negative 2A. Next, I'm going to switch to red. Positive 4 times A. Positive 4A. Positive 4 times negative 2. That's negative 8. All right. So, yes, sir. What's that? Area model. Area model. All right. So we start with A squared. Are there any other A squares? No. Okay, so I bring that down. A squared. Next, these are usually diagonal side by side, and we can combine them. What is 4 minus 2? 2A, that is correct. And last but not least, minus 8. All right. So that's the area model. But what is the method that you usually did before? Distributed property. So let's go back to the original, and we're going to use distributed property so you can see both methods. Here we go. I want you to circle the first A, and you're going to distribute to the second binomial, to this one and this one. So here we go. What is A times A? A to the second, A times negative 2, negative 2A. With red, I'm going to box the second term of the first binomial and distribute. What is 4 times A? Positive 4A. What is 4 times negative 2? Negative 8. Now, I do want to make a comment here. Look up to the screen, because this is where your brain, check this out. For some of you, it's not your fault because your brain gets a little bit short-circuited at this point. Watch. What did we just do here with distributive property? We did what? Multiplication, yes? So we're done with multiplication. What do we do at this point now? At this point, I'm gonna even put it in green. We're gonna combine. Combine, what does that mean? We're going to add or subtract. So check this out. If I was to cover this and I ask you to combine like terms, do we know how to do that? Yes, we've been doing that for the past week, right? So therefore, let's combine like terms here. Let's go. Is there another a squared? No, bring that down. Is there another a? Yes, right next to it. So we got 4 minus 2, that's positive 2a. And at the end, my constant is -8. Did we get the same thing as the area model? Yes. Either method works. All right. So once again, you're going to be allowed to use any method, but for right now, I do want us to practice our area model. Okay. So I'm going to give you another binomial times binomial like this one. I want you to use the area model. Here we go. Copy this. Example 3Q. 3x minus 5 times 2x minus 3. Use the area model, that one. Let me get you started. Here it goes. And let's see, help us set it up, please. Let's see, Steve, help me out. What do I write here? (3x) line across. And then -5, there it is. How about on top? 2x line down. -3. All right. I'll give you some time for that. Find me the product and go. All right. So just so that we can go through the process, somebody is going to help me multiply this times these two to fill this up. Help me with that, please. Noel. 3x times 2x is 6x to the second, and 3x times -3 is -9x. We're multiplying, yes? So be careful, your brain's gonna be doing like, what's going on? All right, let's go to the second layer. -5 times these two again. Help me with this part, Delilah. -5 times 2x is -10x, and -5 times -3, 15. Hands if you got that. All right, and here we go. Do we have any other x squares in here? No, bring that down. 6x squared. Combine these. What is -10 and -9? -19x, and bring down plus 15. Hands if you got that. All right, I think we got this, yeah? Piece of cake. So let's see on your screen, I'm sending you a poll from 1 to 5. How comfortable do you feel with what we've been doing so far? You're like, Q, come on. Crank it up a little bit. Yeah, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. Okay. All right. Shall we crank it up a little bit? Yes, Mr. Q. All right. This one, too easy. Bam, copy that one. Example 4. We're going to use the area model. Area model. Copy that, please. Example 4, x plus 2, parentheses, -4 plus 2x squared minus x. We're going to use the area model, so make a robust area like so. All right. Help me set this up, please. Let's see, Kayla, what do I write here on the side? x, line across, positive 2. Okay, thank you. All right. How about over here on the top? Help me with this, Romo, Diego. In standard form, by the way. I want this here, but in standard form. So what do I write first? 2x squared, line down. That is correct. That one's done. Next, negative x, line down. That is correct. That's that one. And negative 4. Yep. All right. So I'm going to start with blue. X times 2x squared. Joel, go. Two x to the third. All right. What is x times negative x? Negative x to the second. And x times negative 4, that's negative 4x. All right. Jaden, go. 2 times 2x squared. 4x to the second, positive. Next. Negative 2x. Next. Negative 8. All right. Then, do we have any other cubes? No. Bring that down. 2x cubed. Combine these. What is 4x minus 1? I'm sorry. 4x squared minus 1x squared. 3x squared. Bless you. Combine these. Negative 2 and negative 4. That's negative 6x. And at the end, bring down the constant. And we're done. Let's go. From 1 to 5, how comfortable are you with these? Binomials times trinomials. Okay, not bad, not bad. Yeah. Shall we crank it up a little bit more? You're good? Yeah, me too. I'm good, but let's crank it up. Copy this one, please. Example number 5. Area model, please. That means you need to make a more robust type of area. There it is. And they give us for number, this is example number 5, negative 3x minus 72x squared plus 6. And the second polynomial is negative 2 plus 4x plus 5x squared. And remember, as you're setting up on your area model, make sure you're writing it in standard form. Okay. All right, help us set us up, please. Here on this side, help me write something here, Briseda. Where do I start? Negative 7x squared, line across. Next. Negative 3x. And positive 6. Okay. And the top part, Dylan, tell us what to write in standard form at the top. Line down. Positive 4x, line down. Negative 2. All right, I'll give you time to multiply that out, see what you get. Copy and go. I'm gonna have someone help me out with the top one. I'm gonna start with blue. This one times all 3 terms. Help me with that one, Frida. What'd you get here? To the power of 4. Negative 28x to the power of 3. Positive 14x squared. Hands if you got that. Okay, not bad, not bad. Continue the next layer. I'm going to do in red. Help me with that, Lysandra. Negative 15x cubed. Negative 12x squared. Positive 6x. Yes, so far so good. All right. The bottom one in green, help me with that, Julian. What did you write here? I'm sorry? Oh, okay. Help them out. Isabella Gradillas. What do I write here? Positive 30x squared. Positive 24x. Negative 12. Hands if you got up to right there. All right. Let's see. Highest degree is to the fourth, so I bring that down. Negative 35x to the fourth. Are there any x cubes? Yes. Negative 15, negative 28, that's negative 43x cubed. Combine these, we end up with positive 32x to the second. Combine the x's, that's positive 30x minus 12. Hands if you got that. All right. Hopefully for tonight, make sure you go to Canvas, guys. Have fun. See you guys tomorrow. Bye.